Let's draw the Lewis dot structure for C2H2. In order to draw our Lewis dot structure, we first have to figure out the number of valence electrons in our compound. C2H2 is made up of two elements, carbon and hydrogen. According to our formula, we have two carbons and two hydrogens in our formula. Because carbon is in group 4, it has 4 valence electrons. Because hydrogen is in group 1, hydrogen has 1 valence electron. So the total number of valence electrons due to carbon is 8. The total number of valence electrons due to hydrogen is 2. So the total number of valence electrons in our compound is 10. In order to figure out which atom goes in the center, we first need to figure out which atom has the most number of unpaired electrons. Each carbon has 4 valence electrons, so we can place each valence electron around the symbol C, and each hydrogen has 1 valence electron. Because carbon has 4 unpaired electrons, and hydrogen only has 1 unpaired electron, that means that our carbon is going to be in the center of our atom. Now, this compound is a little bit unique in that we have 2 carbons, and carbon is our central atom. This means that both of our carbons are going to go into the center of our compound. And the hydrogens are going to go on either side of our carbons. Remember that each atom is connected together with 2 valence electrons. Here I have 10 M&Ms representing our 10 valence electrons. So this hydrogen and carbon are going to be connected using 2 valence electrons. This carbon and this hydrogen, this carbon and this carbon are connected using 2 valence electrons. And this hydrogen and this carbon are connected using 2 valence electrons. That only leaves me with 4 valence electrons left. Just like before, I want to add my valence electrons to my outer atoms first until my atom either has an octet, meaning 8 valence electrons around it, or its exception. Hydrogen is an exception. Hydrogen can only have 2 valence electrons around it. So this hydrogen has 2 valence electrons around it. It cannot accept any more valence electrons. This hydrogen has 2 valence electrons around it. It cannot accept any more valence electrons. So that means that the only spaces that I have available to put valence electrons are on my carbons. This carbon has 2 4 valence electrons on it, and this carbon has 2 4 valence electrons on it. It doesn't really matter where I put my valence electrons. I'll just put both sets of valence electrons on this carbon. In order to make sure that my Lewis dot structure is correct, I have to check each atom to make sure it has either its octet or its exception. I'm out of valence electrons, so I can't add any more valence electrons. I just have to check to make sure that what I have meets the rule. This hydrogen has 2 valence electrons, and hydrogen can only have 2 valence electrons, so this is correct. This carbon has 2, 4, 6, 8 valence electrons, so this carbon is correct. This carbon has 2, 4 valence electrons, so this carbon is missing some electrons that it needs. And this hydrogen has 2 valence electrons, which is correct because hydrogen is an exception to the rule and it can only have 2. So what do we do when we're out of valence electrons and we don't have an octet? So if we don't have an octet, then we look at where we have lone pair electrons, and it might be a little bit easier to show the lone pair electrons if I substitute my bonded electrons with a line. So I'll go ahead and substitute those two for a line, these two for a line, and these two for a line. Might be a little bit easier to see where I have lone pair electrons. So I have two pairs of lone pair electrons on this carbon. So if I have lone pair electrons next to an atom that needs electrons, I can take away a pair of electrons from the atom that has it, and I can share those electrons with the atom that needs it. So when I do that, I see that this carbon still has 2, because remember each line represents 2, 2, 4, 6, 8 valence electrons. And now this carbon has 2, 4, 6 valence electrons. So this carbon is getting closer to an octet, but it's not quite where it needs to be. So again, if I have lone pair electrons that are not part of a bond, and I'll go ahead and substitute those electrons for a bond, then I can take away the pair from the atom that has it, and I can share it with the atom that needs it. Then I can count to see if I have an octet. I have 2, 4, 6, 8 valence electrons on this carbon, and now I have 2, 4, 6, 8 valence electrons on this carbon. So if I substitute my line for my 2 valence electrons, this would be my Lewis dot structure of C2H2. And the way that we would draw that is H single bonded to a carbon, triple bonded to another carbon, and then single bonded to a hydrogen. Everything has its octet, and we have only used the 10 valence electrons that we are allowed. So this is the Lewis dot structure of C2H2.